This morning. I'll start with a bit of a retrospective, and then we'll jump into some hands-on exercises. So yesterday, we had a rather full day. In the morning, following the retrospective, we dealt with a lot of additional basics associated with building models in AnyLogic. So we went, and for the first time, we added state charts. I guess we had done interacting state charts the day before, but we added state charts for individuals that allowed them to proceed among a set of states. We discussed different types of transitions associated with those states. You'll recall that the state charts simultaneously capture the states themselves, the division of a person's states into categorical, discrete distinctions. So yesterday, susceptible, infected, and recovered. And other times it might be normal glycemic, pre-diabetic, and diabetic without complications, and diabetic with macrovascular complications. So we have states, we have actions, changes to that state, which with a state chart are most commonly represented in the form of transitions between states, although we saw some additional types of actions later, actions where a person would infect another person by sending a message, for example. And then rules that govern when do those actions fire. And as Jeff had noted early on, the structure of those transitions, from which state they come and whither they go, provide a set of basic rules that are very obvious visually. But as we saw yesterday, there may be additional rules that govern the firing of a given transition. Can anyone give me, other than the fact that to follow a transition you have to be in the state from whence it comes, what was another possible trigger that might be required for a certain type of transition to go off? We saw it yesterday in our model. What other thing besides just being in a certain state, being in the susceptible state, might be required to fire a transition? There. Yeah, a message, the receipt of a message. Remember that? We had a message that indicated exposure to some pathogen. And in the very simple representation we captured, we had individuals who were susceptible and received that message. They were automatically infected. In general, we might have a branch, so they have some chance of being infected. Otherwise, they retain their stay in the susceptible state. Where do we see branches before? These sort of conditional transitions, which would maybe flip a coin with a certain probability. Its heads maybe 95% of the time they're not infected, 5% of the time they are. Where did we see branches the previous day? Does anyone remember? Yeah, dividing the initial population into a set of states. But in general, branches are used not just for the initial state, although that's a worthy use of them, but also to handle things that come up dynamically in running the model, such as reaction to messages or reaction to actions. Think about a peer educator who speaks to somebody about the importance of safe sex and whether that goes to their heart and they start adopting practices that are consistent with it. So we have rules of various sorts that are often captured in state charts. It's not the only construct in AnyLogic that captures all three of these. What's another built-in sort of construct in AnyLogic that captures states, actions, and rules, but in a continuous context? Remember, state charts are for categorical distinctions. I'm uninfected, I have latent TB, and I have uninfectious active TB, and I have infectious active TB. Those are sort of categories that I could be in. But how about for continuous state? A stock and flow, yeah, it's another way that sort of packs them together for continuous state, for movements that affect my state in sort of ongoing continuous ways. And turns out that stocks and flows often capture continuous change, but as we noted, they can capture continuous variables, things like weight, things like strength of immune response, things such as stress level, what have you, and or perception of risk. And it might be affected through episodic exposures or moments of truth. A particular episode whereby one feels evidence of racism, and the stress response is immediate and sudden and significant, but still on a continuous scale. So we can capture those mixtures within any logic. Now, yesterday morning, we built up the state chart, and we layered the individuals having those state charts within networks. What sort of network did we use yesterday? It was a distance-based. So a given pair of people were connected if and only if they lay within a certain distance of each other. And we had a distance, per good modeling practices, characterized by a parameter, parameter that could be specified to that model. Where did that parameter live? We wanted to specify that parameter in an experiment, on a per experiment basis, say, to allow people to have more connections or be more tightly circumscribed in to whom they're connected. Where did the assumptions for that get set? They got set in the experiment. So where did that parameter have to live? In Maine. If it had lived in person, that would have been, at a conceptual level, fine, but the problem is there isn't a neat way of specifying it down there in person from the experiment. So parameters are used, important point, parameters are used to undertake two functions in any logic. First function, they encode some assumption. Second function, they communicate that assumption from the point of creation to the actor that's being created, or the construct that's being created. So if we have experiment, the experiment actually is responsible for bringing Maine into existence, the class, not the state. And when it's brought into existence, the parameter assumptions specified in that experiment get told to Maine. And Maine says, yes, ma'am, goes off and undertakes the model with those, runs the model with those assumptions. But if we have a person and the person is associated with parameters, where are those parameters specified? So suppose we associated someone with an income. Where would we specify their income? It's not in the experiment. Where would it be? The parameters associated with person. Person has an income, so it's a parameter in person, to be sure. So you're bang on with that. But where is the particular assumption about how much income a particular person has? Where is that specified? Sorry? In the population. It's in the population in Maine. It lives in Maine. So this is important. Remember that person class describes personhood, personness, what it means to be a person with respect to the model. And we have some models that are intensively detailed with respect to their depiction of a person and the various states that they can be in, and are often really, really data grounded. And then we have other models where it's a very, very stylized representation, but it's sufficient to give some real insights, some profound insights. It can help in theory building. And whatever that representation is, it kind of represents personhood in the context of this model. And so it's important that we don't specify for each person within that person what their assumptions, within the person class, what the assumptions are typically. Typically, we want to vary, for a given assumption, say has given representation of person, which has an income, we want that income to be able to be varied based on different contexts. Like if they're in one city, it might be one distribution associated with that. Another city might be another distribution. Or maybe we want to pull those numbers in from a database or from a spreadsheet. And so that that information is not specified in the person class, which describes personhood. Rather, it's specified in the context in which this particular person circulates, like one city or another city. So it's associated with the population as the most fundamental example. So in the population, do you remember that? Does anyone remember that? We actually specified in that model we had yesterday, here's the population, and within this population, hey, come on. Okay, hey, here's the population, and within that population, we had income drawn from a log normal distribution. So for each person in the population in turn, the first person be created, the second person, and the third person, it's drawing from this log normal distribution in an IID fashion. And it's independent and identically distributed. So it's drawing from this. Now, although I didn't show it, we could have this distribution, per Chris's comment yesterday, be contingent upon the sex of the person. So which distribution we use is based on their sex. So we could have income depend on their sex. Or we could have education level depend on their income and sex, or something along those lines. So here we can capture conditional dependence of these rules for generating income level, these distributions based on other attributes of a person. So we can have that kind of conditionally decomposed, or we can read them in from different tables, in a database, because for men and for women or what have you. I didn't go into that, but it's worth thinking about. So the point is that with the person as well, it's with the main class, it's created by the experiment, and so the assumptions are specified by the experiment. For a person, they are created by the population, as the most common case, so the assumptions about them are specified by that population and communicated to them with that parameter. Does that make sense? That's kind of the conceptual model to use here. And this holds even for hierarchical models. One of the models I provided you, I'm almost certain, is a hierarchical model where you have people, and the people are nested in cities, and the cities are in, more global region. And you have the cities connected to each other with one network, and the people within a city connected to each other in a different network. And so a given person's attributes there are specified by the city in which they're located, the population for that city, and the city's characteristics, its size or average income or what have you, is specified by the region, population of cities. Okay, so it's a consistent model, but it's important to understand it. And at a practical level, we will sometimes put parameters that, they're about a person up in Maine, so we can easily vary them by according to the experiment, so that we can easily set up new experiments. So that's good. So we built up this model, and within the model, we placed those people within those networks. We used a distance-based network. Now, some of you may have noticed when you chose that distance-based network, there were many other networks allowed. There was something called a random network, which goes by many names. Erdos random network, a Poisson random network, Bernoulli network. It goes by different names. But basically, it's a network where there's simply a probability any two people will be connected. Flip a coin for any two people as to whether they're connected, a weighted coin. So there might be a 10% chance any two people in the population are connected to each other. And there's a set of other networks too. Scale-free network that exhibits power laws associated with the number of people to whom a given person is connected. It makes use of the Barabazi and Reza algorithm for building up a scale-free network. Small world networks which have this mixture of local connectivity with global connectivity. So most of my connections are with people locally, but I have a few connections with people at a long distance. few connections that often make all the difference when it comes to the dynamics. There are ring lattice networks, which are kind of a one-dimensional local network. And then there's the distance-based network. And then there's user-defined networks. So some of the models I provided you actually allow you to build up your network from reading, say, a PIAC file. I don't know how many people here know PIAC, but it's a popular social network analysis tool. And it can read in data from those files and construct a network with, the same people, the same nodes, and the same vertices and the same edges or links between them. And so it can read it in and build that network within the simulation, and we can then conduct simulations with it. So Winchell, I'm not sure if he's in the room right now. He's probably he's outside right now, always working on some amazing thing. He actually has a very nice little model which he built where people's network connections over time are varying dynamically using data that we gathered during the flu pandemic in 2009, 2010 using sensors. So we have a very articulated research program with smartphone-based sensing that some of you are aware of. And this was using data from proximity sensors to detect who was in contact with each other during the flu pandemic for 3 months. And he fed that data into the simulation model directly so that over time, if you look who's connected to who, it matches what was collected with those smartphone data. And you can, for example, simulate the spread of H1N1 over that network, which we did, with different assumptions about vaccination strategies, for example. Anyway, some very powerful ways that you can read in empirical data and put it into networks, and those networks can be varying. So, Daryl, yeah.
When we go back to your point about the small world network,
yes.
Could that be something to characterize kids and their family relationships, and then when they go out to their school relationships, or is that not what you see that?
Well, okay, so great question. So the question, as I understood it, was small world network where you have this kind of mix of mostly local connections, but a few long distance connections. This is inspired by work of Steve Strogatz and Duncan Watts at Cornell, but it's been very widely applied. Could that be applied to sort of a situation where you have kids who have a family network and then school networks as well? I would tend to actually use a different mechanism for that. The reason is because both of those networks, the family network and then the school network, are in some sense local in the sense that they are structured quantities where an individual is connected to people who are persistently nearby them, just in different contexts, at home or in school. So the way I would do that in any logic, as an example, is yesterday we actually, I don't know if anyone remembers, but when we needed that network to appear visually, where did we go? Anyone remember? Yeah, connections. There was this thing called connections. It was located in person. So each person had some connections, and we could go see it here, right? So if we wanted to look at this, we could go to person here, and it may be hard to see because it's hidden up here, but some connections. And in general, this is kind of the default sort of set of connections. It goes here, but in general, you could have several of these. So you could have a family network connections. You could have a school connection. So family connections, school connections, or family members, school. Or you could have parents, siblings in school to differentiate the types of relationships there. And those could each be captured by a set of connections. And there'd be different statistics you might compute over those connections, different levels of peer versus parental versus sibling influence, different levels of consistency. We're about to go back to school, each year there might be some turnover at school, but the family unit is somewhat more stable. So my point is that you could capture those through different sets of connections, and that's the tendency I would have. Does that make sense? Scott?
This is sort of plea. Is there any traction whatsoever in the discussion between excellent brain and all?
I'm sorry?
Excellent brain
Yes, we suggested it to any logic about 2 years ago. Or
I sent them the algorithm to actually
yeah. A lot of interest in some quarters in the health space and exponential random graph models, and we long suggested that would be a very natural thing for them to support to better support health issues. And I don't know the current status of the plans for development on that. Yeah. If you can bring the message back to the mothership again, they'll be. Okay. Well, we'll find other channels. Okay. So, ladies and gentlemen, we did see that there could be different types of networks. If you run each of those sorts of networks, you'll find different dynamics associated with it. It turns out a small world network can allow infection to jump. It spreads locally, but it can jump across the network. A scale-free network has these hubs, these people have lots of connections. And if we're thinking about social influence, or we're thinking about pathogen, we're thinking about any sort of contagion process of ideas, knowledge, attitudes, beliefs, norms, or pathogen, those people who are hubs tend to be most likely to get that early, that pathogen or that idea, that meme, that rumor, and most capable of passing it on. So they have particular importance in the network, particular importance because they're more likely to, say, be infected and more likely to get others infected if they are infected. So often they're the tail wagging the dog, that small set of people who are at the core of the network who have lots of connections. And there's been a lot of interest in social network context and, targeted individuals who have lots and lots of connections to influence them or to, in social marketing to help encourage healthier behavior so they can inspire others or what have you. Anyway, we could examine all these things. We don't have time. As Jeff says, the hardest part of this is figure out the 95% we don't do. But we then did build up that model further to see some aspects of the spread of infection. And we added some statistics to this as well. Do you remember that? We added those statistics. Where did those statistics live? Anyone? Where do we define them? In the population. And I have some thoughts. I think actually it could be done better and statistics could be described more easily and more flexibly. But the point is it is a very useful mechanism because you can fairly declaratively say, what statistic do you want to collect and what are the criteria for it? And boom, set it off and have it work, which is pretty nice. So we added those statistics and then we created, we saw some of them changing by going and clicking on the population. Do you remember that? Click on the population, you could see them change in real time. But we also added a graph. Do you remember that? We added a graph that showed some values of some of those statistics over time. And it demonstrated disparity. I also used that to try to trace through going from kind of a model characterization using these conceptual models, try to trace it all the way to an actual built model. And I did place that model up on the site. I meant to go do it last night, but I went home and slept. So I didn't do it last night. I woke up early this morning and I did it after my run. So it is up there on the site. We'll be making use of it again today. Okay, that model. We'll be extending it. So the afternoon. So over lunch yesterday, you heard about some tools that we've been working on, and one of the tools, the basic mechanisms or the basic functionality of it have now been incorporated in AnyLogic, the sort of tracing things happening to people. And one of Dylan's things that of innovations has also been incorporated in the form of a bio browser. This is functionality that we sometimes use with ModGen, for example, in our ModGen projects, but now it's been incorporated in AnyLogic as well. So you can browse someone's history according to events which happened to them. So they experienced heart disease, say, between these periods, or starting at this time, and they presented for care at this time, and saw a cardiologist at that time as events in their life. Both states they could be in and kind of states of of health or states of attitude, and then events, which is kind of useful functionality in my view. So this is stuff we've been experimenting with, and it's great to see it. We've been urging AnyLogic to incorporate it to speak to health issues, and it's good to see it there. But they also showed some functionality for recording automatically which runs are made with the model. This is very important. Even if you never think about using that functionality as provided by our tools, ladies and gentlemen, you should think about at least having a lab notebook then where you write down the runs you make with the model. And you should be saving versions of your model away so you can come back to them easily and keep track what run output with what assumptions were run with what version of the model. I'll see if I can hit on this tomorrow when we discuss some best practices, but it's really important for the sake of reproducibility. If you get that paper and revise and resubmit in Nature, and the reviewer says, I love this paper, we urge the editors to expedite publication, we'd just like to see one more run. And, we'd like to increase the number of realizations from 100 to 200, over which the non-parametric statistics are calculated to demonstrate the greater efficacy of one intervention. And you go back and then, oh God, which version of the model was this created with? Do I have that anymore? What parameters were there exactly? You don't want to be in that situation. You want to be in a situation where you can easily go back and reproduce it. And Priesri's tool helps to do that, but your ability to do that is not contingent on that tool. Your ability to do that is contingent on good record keeping in whatever form. So having a lab notebook where you can write these things down, write down observations so you can be clear about what you've learned is pretty important. And I would urge you to put that in practice. It's not a tool thing. It's a good practice. It's a best practice. Also talked about over lunch was Winchell's tool for exporting to R. We tend to use AnyLogic for interactive visualizations and kind of seeing things as the model runs and some basic statistics and visualizations, but to do heavy lifting, to summarize things in a serious way, to run our non-parametric statistics, to create very nice diagrams, to summarize things nicely across many, many realizations, we tend to export to R as our tool. You could export to other tools. It's just we do find R particularly flexible, and we use it for a lot of our other work in machine learning elsewhere. So anyway, Winchell has that nice little tool. It's not that hard to do manually. And this morning, we'll be looking at this issue of how do you collect data from your model and something about how do you export it. So if Winchell isn't around, what can you do to get data out of your model and into tools of your choice, whether it's Excel or R or SAS or SPSS or whatever it is. Okay, so then in the afternoon, and something I was very happy about, we had a longer session, and I was very pleased that I could go and have meaningful, substantive conversations with a number of the groups, and I'm very well aware that I couldn't do it with all. Jeff and I are trying to circulate somewhat ergodically around to sort of talk with different groups. I will aspire today to handle a bunch of other projects where I can come around and talk, okay? So the other thing I want to say is this is a Bootcamp and Incubator. Jeff has been for years trying to nudge me, getting me thinking about the anti-conference format. I don't know if any of you know about anti-conference, but whoever comes or the people that need to be there, whatever happens is what should happen. And I have very mixed feelings about anti-conferences, and I think Jeff does as well. He's just interested in giving something a try, maybe. But what I do believe is that emergent patterns and emergent opportunities are very important for taking advantage of an event like this. So if you folks are just eager to get out there and advance your model, if you want to go grab a TA now and go and work in a room, I'm perfectly happy to have that. I'm not going to take attendance. And I would say that's a very worthwhile thing if that's what you feel would be the best use of your time. But to help inform that, what are we going to do this morning? Well, we're going to be doing a couple things as time cooperates. First of all, we're going to be extending that model a bit, that model we built yesterday. And because I put it on the site, we will be able to, for those who weren't satisfied with their rendition of it, you could download it from the site and start with my version of the model, which you might not be satisfied with either. But it's further. It's a reference point. And we'll extend it to collect some data, see how you collect data about people's history, how you could collect statistics on the model that go beyond with what you could collect easily with normal statistics cross-sectionally like we saw yesterday. And we'll probably go try exporting some of those so that you could easily get them into your statistical package of choice or get them output for better graphs or what have you. We will also quite possibly be using the time, as time allows, to show how you can represent interventions in the model that are more textured, that are targeted at particular subgroups in a way that avoids hard-coding them into the model. So you can vary them on a per-experiment basis. Say, I want to target this group or that group. And, I want to target them in this way or undertake this intervention for that group. So we'll be probably having a chance to look at that. I would love to add a hybrid component to it by showing a clinic flow so that those people who are sick present for care at a clinic, flow in through a discrete event model in the clinic, are cared for successfully or not, and that affects their state, and hoping we might get that. But I also have a very keen need that I understand some of you are very interested in, to have Dylan present on building up a GIS model with GIS. And so we're going to have to look at the time and figure out how we can best use the limited time available to us this morning. If any of these things are of great interest and they don't get covered, come up and tell me, and we'll make sure they get covered either in a little thing this afternoon or tomorrow morning. Okay? But otherwise, I would like to use a lot of this afternoon again for projects, so we can really push those forward, and so I can visit and help guide, and so Jeff can as well. Any questions? Any questions? Yes, Daryl? Okay.
Sorry. Yeah, just for the university, we have the student version.
Yeah.
But when I tried yesterday to download one, I couldn't open because it says the version doesn't match.
Is this 7.2 or?
Mine probably not. Like we downloaded a year ago. I think it's 7.1.2.
7.1.2 should be compatible. So I'll get one of the TAs working on it. Raheem, could you come up here? Are you a big Mac user, Raheem? Okay, why don't you get someone who is a Mac user, because it could be related to Mac attack. Okay. Yeah, Daryl.
I think to jog you back to something you said about 15 minutes ago.
No, this is great.
You were talking about exposure and networks, and you mentioned just quickly social marketing.
Yes.
Now, is that something you're trying to say is something we can depict via these larger networks?
Oh, well, yeah. I mean, so great question, Daryl. As I understand it, the question was in my you can use the term ramblings, soliloquy, in my stream of consciousness, in my introduction, I commented with respect to networks that they could potentially be of use in relation to social marketing, and yes, Winchell, feel free to use that if you'd like to. Thanks. This is like the arch elf. So with respect to the social marketing side, social marketing takes place within a process. It's a process, and as such, it can be represented quite naturally within a dynamic model. So I do think this is an area where dynamic models can be very, very useful, depicting network-based processes that are explicitly making use of the network, perhaps seek to build network connections or exploit existing network connections to spread memes, ideas, healthier attitudes and behaviors. And I believe the sort of models we have been working with yesterday, the agent-based models, are particularly natural for representing that. There are insights that can be secured using aggregate dynamic models at a high level, but if you really want to exploit social connections and you want to reason about on whom to intervene, who might be highest priority to recruit, who might be most effective, typically you're going to want to represent a network structure explicitly. I would also note some of the work that years back, I think it was Penny Ha and Ellen Shield were pursuing with sort of complex interventions which aspire to build connections between people. So, to influence the community's health, not merely by educating people, but by forming new bonds between people. And some of our work that we're involved with, the Good Food Junction here in town, has that flavor as well. You bring together people for cooking classes for healthy foods, and you're not only teaching them cooking, you're forming social connections, which then provide support long after the cooking class is over. And so it is with this boot camp. We hope that this boot camp is not only an opportunity for educating, but it's an opportunity to bring people together, to link people up, and to use the site to do this more effectively. So I do think models are can be extremely effective tools in examining intervention designs which seek to exploit or to change network structure. Yes, go ahead. Oh, yes, sir.
Really quick request. There's been a bunch of PowerPoints that have been presented at lunch or others that aren't on the site.
Okay.
If we could just get them, it'd be helpful.
Sure. I'll see if I can ask those who have presented to make sure that those are all available. We've tried to do that in previous boot camps, but we'll try to do it for this year as well. So thank you for bringing that up, and poke me if you don't see them by tomorrow. Okay?
I'm actually curious about what you thought of the work of Dr. Carley's dynamic network analysis, because not the pre-planned part, because that's actually not the core part of her work, but the fact that she models ideas and beliefs as their own network nodes and represents, like, everybody who believes in something or something like that is actually a connection between that person and this idea, which is very high level, complex network. And then at that point, the actual belief system is amenable to social network analysis. I'm wondering what you thought about that.
Well, that sort of strategy is not unusual. I'm actually not familiar with her work in any sort of detail, so I can't speak directly with confidence about her work and trade-offs. But in terms of the strategy you've articulated, that's quite a notable strategy within social network analysis that I've seen applied elsewhere. So my colleague Anne Jolly, anyone know Anne from Public Health Agency of Canada? Yeah, a wonderful researcher person and someone who's also very, very committed to health arena. And she's done a lot of work, including the downtown east side of Vancouver with intravenous drug users and with STI networks around Canada with social network analysis. And one of the things she's found most helpful is, for example, to put places as nodes within a network. And so you have people and places. And one of the reasons is, well, when it comes to STIs, people are often a little bit hesitant to tell you with whom they've had interaction directly, particularly if their spouses come along to the STI clinic. But if you ask them where they hang around, where do you spend your time, they're often very willing to say those things. And by incorporating the network, you can undertake certain types of analysis using social network tools that are quite insightful. So what I have to reserve judgment on is the degree to which I would pursue a similar strategy with respect to dynamic modeling in a tool like AnyLogic. I would tend not to represent place in that fashion within AnyLogic, just because the tool doesn't require it to get insights, and there's more natural representations of space and location, including GIS components and including other representations would be different populations or different locations which themselves might be represented using other types of agents but not arranged in a network. So what I lack conviction in, and I need to sit down and think about it, is the degree to which incorporating them actually into the network as nodes is, I think it's a perfectly fine pragmatic strategy. I've no bones about it for social network analysis, but I've yet to be convinced that it's needed to secure the same insights in the additional insights in the context of dynamic modeling. I probably wouldn't go about it. I think social network analysis packages, of which we've used a number, Payek, Gephi, Guess, some of them are very powerful and very, very helpful, but they have certain, like all packages, they have certain limitations to what you can do with them. And I think one of the limitations is they're really, really good at capturing vertices, nodes, and edges, lengths, as primary constructs. And the analysis is centered around those. So if you're going to need to incorporate place, doing so as a node is one of the most obvious ways, rather than just leaving it as an attribute of each person. And you can look at things like the centrality of a place, or the degree centrality of a place, or betweenness centrality, I suppose, of a place, which might be useful. I wouldn't feel the impulse to do that in a dynamic modeling context, just because the vocabulary is larger and the set of possibilities of how you incorporate it is larger, and you might be obscuring certain types of analyses. But I have no bones to pick about it. There's some really neat work being done in that space. And in general, this space of dynamic networks, I think is quite promising. The work of Martina Morris and Kretschmar formed the basis for some early HIV modeling work we did about a decade ago for Papua New Guinea, where we had dynamic networks in AnyLogic 5, with people interacting over them according to the theory that Martina Morris gave related to network concurrency. It's great stuff. More recently, there's the whole Sienna work over in the Netherlands, and Tom Schneider, I think, is the primary lead with that, sort of an actor relationship models. And people can quibble about whether it's just another form of simple agent-based modeling or whether it's something different. And again, I don't have dogs in fights about labels. Richard Feynman once said, he said when he was growing up, his father told him 95% of the arguments in the world are about labels. And you'll spare yourself, people would spare themselves a huge amount of grief if they could get over arguing about labels. And he said he grew up and he put his father's aphorism to practice, but when he became older, this is the Nobel Prize winning physicist, when he became older and after his Nobel Prize, he realized that his father was probably off. In due respect to his father was off. It wasn't 95%, it was more like 99%. And Dwight Eisenhower said, someone asked him, how did you win all those battles in World War II? How were you so successful? And he said, actually, I won World War II not by the battles I fought, by the battles I didn't fight. And that's a battle I don't want to fight. So want to pick our battles carefully. And so it is with shaping our research questions for our models, too. Okay, any other questions, though? I love these sort of back and forth discussions. Any other questions before we get our hands on? Were you able to figure out anything with that? Oh, okay.
Can I use the other?
Okay, so is the issue with version?
Yes.
Okay, so maybe I'll just make a comment, and Winchell could give most of this boot camp, he could tell me if there's additional things I need to say. But one important point about AnyLogic, and it's, I'm not here to sell AnyLogic. I'm here to help evaluate as a tool for your needs and help teach some things if you think it is responsive, and talk more broadly about use of these methods. But with AnyLogic, one of its shortcomings, downsides, is the fact that if you build a model in one version of AnyLogic, say 7.1.2, often you can't load that model even in a model version, even if, on another computer you're running 7.1.0, you still can't load that 7.1.2 model. It's very finicky, persnickety, about what version you use to build the model. And in fact, it shows it in it. Up at the top, it says what version it is. And in general, it is unhappy and refuses to load it, an earlier version. So is that what happened?
Yeah, exactly.
Okay. So my condolences. It's something we have to be careful about, and it's one of the reasons we didn't go to 7.2 for this particular boot camp. We were tempted. I was on the edge, but we weren't sure we could roll it out in time. And secondly, we didn't want a situation where we start experimenting with it, it stamps some of our models, and then we can't go back to 7.1.2, and some of you have 7.1.2, and all hell breaks loose. Yeah. Okay. Great. Any other questions or comments? Yeah.
But for that reason, we and other knowledge teams are considering abandoning any software package and going to just write it themselves.
Yeah.
Because when you're on a tight timeline and running into a problem like this,
yeah.
In 1 or 2 weeks.
Right.
Your thoughts on
Sure. Thanks for the question. So the comment was that this issue with persnickety sort of attitude with respect to versions is not limited to AnyLogic. It's found in many other simulation packages as well as other software packages. And the comment was, well, look, if you're on an aggressive timeline, you have you're working with tools that are where you're depending heavily for your progress in your work. And for delivery of value and on deadlines, that sometimes you're caught up by these silly little things. You're dependent on those things, and you're dependent on this package, and it catches you up with little glitches. What about building your own software package? Well, for doing simulation modeling. So I'm a computer scientist, and I'm a specific type of computer scientist that's a software engineer. I teach software engineering, multiple software engineering classes, and I'm someone who's been for portions of my life a professional software developer. So this is an issue I can speak to with some perspective that's grounded. It's certainly a common attitude among computer scientists that, look, this package is not what we want, or it has these. It's not exactly what we want. It has these shortcomings. Why not just build it internally and use that? And truth is, we build a lot of our software here. We build a lot of tools. We built IEPI, this tool for smartphones, specifically for health, with all the security issues that means, all the features it means, rather than using, systems out there that are very, very generic and not really well fit to it. We have coded our own simulations. Kurt has coded up his little simulation platform for one of his models where others didn't meet our needs. We tend to use many platforms for different needs, be able to switch between them. So, at one time or another, we've used NetLogo, Repast, ModGen, SDML. But in general, we've tended to use AnyLogic as our main platform. Why? We're surrounded by computer scientists, surrounded by talented software development talent like Winchell here and Dylan. Why would we use an existing package? It hasn't been without thought. There have been times where I've said, maybe I'll throw in the towel on AnyLogic and switch to a different package. Why have we stuck with it? Well, there's a couple reasons. One of the reasons is opportunity cost. The effort that it takes to build up your own package, I could have put that effort into other activities that would very materially advance particular models, very materially advance different lines of research. It actually requires quite a bit of effort to maintain to build up a software package for simulation modeling from the ground up. Even more so to make it industrial strength, to make it a model that works reliably, a modeling package that works reliably, and in my experience, having developed software here in the university for many systems, I've come to the conclusion, regrettable, I wish it weren't so, but it is, that a university is a difficult place to maintain software for a couple of reasons. It's hard to get the operational funding you need to maintain it. Grant agencies are not awfully keen about giving you a block of funding for maintaining software. Also, there's just high turnover with my students. I may have a student like Dylan who's built up one of our big systems, but he may walk out the door at any time. He may go to Australia. He may decide his interests are different, and then I've lost my major software developer. Also, students offer a poor delivery of opportunity because of other really important things for them. Students have theses, students have obligations when it comes to classes and so on. And we find it difficult to sort of predicate our work, building it on top of students for really industrial strength software. It's not fair to the student to sort of count on that. Now, staff members, yes, we can get, but it's hard to get funding for staff members. Open source communities are great. I'm a big believer in open source. We've open sourced a number of our projects. And if you can get a community going, like the OpenM community is trying to get going for ModGen's sort of group, I think that's great. Building your own, I speak as a software developer, it certainly does not avoid versioning issues. It just means that you have a little bit more flexibility because you often will have talent that can resolve those things on the fly. For me, it's too risky to do that, and I have limited energy, and I want to put that energy where I think it will have the biggest gain. And even though I have big disagreements with how AnyLogic does certain things, even though I think it should be done different ways for different things, I think there's a huge amount of value there. I think they've gotten a lot of the basics really right, and we're sort of nudging them in other directions quite successfully with respect to other things. So what we're doing is kind of building up a tool ecosystem that works with AnyLogic. Maybe at some point I'll decide something different. I mean, I'll be frank with you. We do have, and AnyLogic's aware of this, our own simulation software. We do have simulation software that is declarative, that doesn't require Java programming, that seeks to make use of agent-based modeling just as easy as creating a system dynamics model graphically with stocks and flows. We put a lot of effort into this, but I don't fool myself into thinking it's industrial strength. And once other people start being supported, I don't know that the university is a great environment to do that. It's just too much stress for students. It's just the timelines are wrong. The hiring flexibility is off. And we're not in a position to kind of deliver value on a sort of continuous basis through the year, and we just don't have the financial mechanisms to kind of make it all sustainable. At least, mind you, I'm quite naive, I suppose, in these things, but I'm not an empire builder, and I don't understand how it would work to build to build from the ground up a software package within my group that would be sustainable reliably. And one of my fears is, could I do it technically? Oh, most certainly. Would it be fun? Oh, it'd be a hell of a lot of fun. Boy, would I love it. Could I do it better than AnyLogic? Possibly, but they have a lot of resources. They have a lot of bright Russian university-trained folks who are scarily bright. And I find more help by sort of nudging them than I'm comfortable betting everything on doing it myself, and then find, funding doesn't come through, and we have to abandon the project for a couple of years, and it becomes obsolete, et cetera. It doesn't seem to me, for me, the university is not a safe environment to do it. I'm afraid I'd be stuck 3 years now, having built up a great system and unable to support it, lots of unhappy customers because our funding operationally has been lost. And I'd like to put talents like Winchell's and Dillon's to other use rather than heavy-duty sort of lifting for industrial strength software. Yes, Scott.
Just two other things. One thing in the academic area is that something like AnyLogic provides actually shareability and reproducibility of what you're doing. Because if I use my own software package and someone uses it and I produce a model that I want to say I have these types of results with, it's less likely that people are going to want to trust those results just from a perspective like that, in my opinion. And then on the other hand, in industry has this wonderfully averse reaction to anything that's not open.
What? Oh, yeah. Yeah. Yeah.
All notices Kurt and William.
That's great. Okay. Okay.
Could I put like Michael Long or Winchell or Helen?
Yeah, these two will be okay.
Yeah.
But there's an issue with accountability and whatnot, and so AnyLogic is walking a very, very fine line, and unfortunately in some areas they try to please everyone and end up pleasing no one, as Esau Fable says. But it's one of the, I think those are also other considerations.
Yeah. Thanks for those comments. Sorry, I had to get pulled out because of a financial thing with our accounts. So it's another example of kind of the unstable funding environment and the vagaries of university accounting and restrictions and so on. I'd be very interested in having a discussion about this. I mean, we do actually support one system. Our IEPI system is widely used, and we're trying to maintain it as an ecosystem, but it's a difficult thing. One thing I will tell you is be very cautious about anyone who says, "Oh, come on, let's just do it internally. What the hell? We'll build it. We can build equal to this functionality, in a few months." My short answer to that is that is nonsense, and they don't know what they're talking about. And another really big thing that I think about with building your own software is, you think modeling is hard. You should see, building industrial strength software is really difficult for it to be high quality. And it is so easy to build up a little prototype that kind of looks like it's working and it seems good, but you need to have someone absolutely exceptional to do something quickly that's truly, truly robust. And the fact is that most university folks and computer scientists are not trained to do that. They tend to be way over optimistic, and they don't put in place the quality assurance mechanisms that really make sure that it's a solid piece of work. Dylan's a great software developer. For our IEPI system, I think he had 900 tests in place that would run on it to really develop and even there's areas where the quality needs to be improved. There's no question. So again, this is like serious industrial strength work, and companies do have extra ability to hire people who do user interface design, can really put the effort into kind of user studies, into managing the software so that it's easy to use, that it's extensible, and have the flexibility financially to do that. Short of founding a company and going external, I don't know that I'd have that flexibility. Again, open source is a tantalizing possibility, and our plan is to open source our own software development efforts, but we're not sure that they're going to be responsive. I'll tell you, we had a beautiful system 6 years ago, that worked with AnyLogic and with System Dynamics software for maintaining model versions. So it would do the sort of thing that Pre-Esri system does now, but it would do it all internally. You can compare different. You could run with the same set of assumptions, different versions of a model. You can compare the results. You could summarize it visually in some very compelling ways. You could share those with people across the world really easily rather than just sitting on your desktop. It was great stuff. It was called Silver. We have a number of papers on it, and we support it. We had a lot of people externally interested in it. And the student graduated and, said, yeah, I'm interested in still being involved and leading this, but he was too busy being a software developer downtown. I met him several years later. He said, yeah, I'm still really excited about it, but he was sleeping 3 hours a night to develop software for this company in town. And fundamentally, we just didn't have any money to support it sustainably. We didn't have the talent internally who could come up to speed and learn it and apply it. And so the system basically never got serious use externally. Great system, great ideas. I believe in it strongly. It's the basis of a thesis, but it's a tough world. It's a tough world in academia for software development. And there's a lot of over-optimistic people out there, and I've been burnt many times. We as software developers, our first impulse, just as I said, you go to a surgeon, they want to cut you. You go to a radiologist, they want to stick you in the imager. You go to an internal med doc, they want to give you that pill. You go to a software developer, they want to build you a piece of software. and I mean, we get joy out of it. It's great, but whether it's sustainable, whether it's something you want to bet on the long term, I'm very skeptical. Sorry for the sort of the soliloquy, but yeah, those are some of my thoughts. Other questions, comments? Great. Incidentally, I will say one final thing about that. I'm not an empire builder, but I will say I do think there may be an opportunity for changing things in the way things are supported in academia. It's not a crazy idea that with a combination of open source and some sort of stable support from NSERC or other forms that you could get a stable ecosystem which would do that. So I don't rule it out. I think a lot of my skepticism is based on the current reality that funding is so uncertain, that getting funding for operating expenses is even more hard, and that at least I don't have the resources. In the right environment, with the right support, the right endowment behind it, it could be that it would flourish. And I would put a lot of effort into helping further that. So, I know Steve Gribble very well with the ModGen folks and Michael Wolfson, and I'd like to encourage their OpenM stuff. I think it's good. I have some big differences technically, and some differences philosophically with sort of how they're going about it, but I think it's great stuff. I'd love to see. So it's not so much a matter of it couldn't be in principle done. It could be. It could be done well. but it would have to be with different institutional contexts and different funding guarantees. I think that's a lot of my worries are funding and institutional in nature. Yeah. Okay. So any final things before we dive in? Hands on? Okay. Should we have a quick break and then we'll get going? What do you think? Okay? Great.